குடித்தரும் குரல் 619. To put in simple words, even if the Almighty turns his back, the efforts and hard work you put into will bring you great rewards. A warm welcome to everyone. Hope you're fine and safe. With the blessings of the late Colonel Dr. JEPPIAAR, in the presence of the Chairman and Managing Director, Dr. M. Regina JEPPIAAR, our Principal, Dr. V. Nadarajan, Dr. Salisha A. Stanley, Dean of Academics, heads of all departments, our speaker, staffs, and students, I take immense pleasure in welcoming you all to today's session on by our eminent speaker, Dr. S. VEERAKUMAR, organized by the Department of Electrical and Electronics Engineering in association with Institution Innovation Council. To kickstart our session, now I request our student volunteer, Ms. Nasrin Fatima, to introduce the speaker.
Thank you, Ms. Bharati. Success is a learnable skill, and I welcome everyone who is here to gain the skill. Before learning, let us know who is Dr. VEERAKUMAR and what is he up to in today's event. Dr. VEERAKUMAR started his technical education with Diploma in Electrical in Kongu Polytechnic and Bachelor Graduate in Electrical and Electronics Engineering at Kongu Engineering College. He further MTech in VIT University and PhD in the field of power electronics. And he has 16 years of teaching experience, which leads him as an associate professor level. He has published over 20 international papers. He has done a conference presentation on designing of BLDC controller for sensor BLDC motor at the event Electrical Science ICES 2020 organized by SNS College, Coimbatore on February 2020. His expertise in embedded system, microprocessor and microcontroller, PCB fabrication, embedded system C programming. A heartily welcome, sir. Now the session is all yours.
Okay, thank you. Thank you for introduction. So today topics actually I have planned to present on some recent trends. That is, we are moving to electrification, right? It's an revolution in automobile. So I thought of presenting in that topic. So actually, the electric vehicle, speaking about electric vehicle, so before that, am I audible to everyone?
Yes, sir, you're audible.
Okay. So before going to that electric vehicle conversion, actually, there are two different parts. We can buy a new vehicle and or else we can go for an conversion. So before going electric vehicles, we are having in our mind that will it be an reliable one or we can go for an electric vehicle, and what will be the cost and what will be the duration of battery. So because the battery will be the core thing, and we all having an eye on battery and what will be the battery life, and will it be it won't fire while traveling. So these things will be coming in the mind, and so actually I would like to cover the parts like so what is an electric vehicle and what are the major parts, and how we can able to select the batteries, and again accessories like controllers, BLDC motors, and there are different types of driving techniques. We will be going to see all those, and actually this is a very short introduction about electric vehicle, and again we are long way to go in electrifications. And you may know that coming to the topic, you may know that Ola has launched an electric vehicle, and we all know that it's an revolutionized electric vehicle, and it's very compact, and you can that is, you can detach the battery from the vehicle, and you can put charge as in office or in home. And you know that it's having a very huge storage space, and below the seat there is you can able to load 2 half-waist helmets in the seat, and these are the features. And you may know that you may seeing more electric vehicle now running on roads. And how this happens, and previously also we are talking about electric vehicle, and it's not the case as it running now, because it's having an frequent failure, and you may know that there will be an breakdown in the vehicles, so on. And now that trend has been changed, the people are moving to electric vehicle. And now I will be going to add some slides. I will be going to present the slide, and what are the steps that has been involved in converting the electric vehicle. I will be going to speak how you can able to convert an existing vehicle into an electric vehicle. So it will be a very interesting topic. If you are having any doubt at any of the point, you can interrupt me and you can raise the question. So can I present?
Yes,
Ma'am?
sir. Yes, sir.
Okay.
Yes, sir.
I hope my screen is visible to everyone.
Yes, sir, it's visible.
Okay. So this is the core topic, electric vehicle conversion. And before going to that, you must find out what are the things that you must remember before converting, and how to select the, starting from how to select the vehicle. And there are many steps. So like the first thing we will be having in the mind that either we are going to do the conversion in the cycle or an normal bike or a scooter. And if you are going for a cycle, preferably it will be quite okay if you are going to move around 20 kilometers. So beyond that, it's not advisable for electric conversion. And for your conventional bike, that is bike, regular bike, what you are going to use, the regular bike, it will take more mechanical work. So you know that the engine is just sitting behind, below your petrol tank, the fuel tank, and you may notice that you need to replace whole engine, and you should replace, you should put that type of mechanical arrangement, so it should appear very neat. So if you remove the whole engine, then it will be awkward. You can't able to bring that appearance in case of an conventional bike. But in case of the scooter, you can do anything. It's not exposed, because it's the whole thing is closed, and you can easily fit your that is motor. Obviously, we will be going to use some hub motor, and I will speak on that why we are going for a hub motor. And probably you will be having an boot space, and you will be putting an battery in that boot space. So it's very quite comfortable for an scooter. So the scooter will be advisable. If you are having an workshop with you, and you are having an welder, you can do the conversion in and even in a motorcycle. And next, how you are going to buy the parts. Probably you can able to buy the parts in there are many internet resources. Probably I have bought an vehicle from this India Mart. You can go to the India Mart and you can search the products, and from that you can able to get the contact, and you can speak the vendor directly from that. So I have purchased all the products from an India Mart, and I have get the contact from that website. And next one will be the battery. The battery will be the core. Again, you must select whether we are going for an which type of battery. There are many types of batteries, and again, whether you are going to do your own battery pack. So there are many videos are available in the YouTube, and it will be going to teach you that how you can able to make the battery pack. And from that only I have learned. It's actually, this presentation is an I have converted an scooter into an electric conventional scooter into an electric scooter. So just I will be going to present you what are the things I have done here, so on. Okay, and so next one will be an battery pack. So battery pack, you actually you want to do more research on battery pack. I will be going to show the comparison of the different types of batteries, and how you must to select the battery. That will be that also I will be going to just give an introduction about that. And next one will be about batteries, and again controllers, and again wiring hazards. So because you are going to rewire everything, actually the conventional scooter is fabricated for your, that is designed for your IC engine, that you are going to replace everything from that IC engine. And again you want to do your own wiring in the uh, bike or scooter. And next one, display. Probably you will be going to remove your analog meter and you want to replace that with an digital meter. And next one, charger, and everything, and finally you want to validate their actual results. That is, you will be calculating the battery capacity, and based upon that battery capacity you will be calculating the mileage. So all this will be an paper approach, and this you will be doing some calculations, and you will be finally coming to the conclusion that for this much battery voltage and this much AH, your vehicle will be running to approximately this much kilometer. Everything will be paperwork, and you must validate everything whether you are going to get an actual kilometer range for that given battery. Okay, and finally you are going to validate everything, that is wiring, and whether is there any leakage in that wiring, whether the uh, test points are giving an actual correct value, everything. Okay. And next one, purchase. Obviously I have bought an electric scooter, that is kinetic Honda, which is an 1998 model. And so this is an actual vehicle I have bought from an scrapyard, and this I have bought for the rupees 3,000. It's a very cheap, and actually this is in running condition. While I am getting this bike, it's in running condition. And next one, again I have now finalized the parts, and these are the parts. And first one, the core, the thing which will be going to propel you, is a hub motor. And I have selected the hub motor, and I will say why I have selected the hub motor. And next one, display. And display, you want to select whether you are going for an 48 volt or an there are actually different voltage schemes in your traction system. Starting from an two-wheelers, there are three different voltage schemes: 48 volt, 60 volt, 72 volt. So there are three different voltage schemes are there, and you are whether you are going to work in which voltage scheme. So that matters. The advice is that you can go for a higher voltage range. So if the higher voltage range, then what happens to the current? So we will be doing the calculations, right? That is I equal to P by V. Okay, you know the voltage, you know the power, and you know the voltage, and putting together you can able to find out the current. If the lower voltage, obviously there will be a higher current drawn by the motor. And if you are going for an higher voltage, then the current drawn by the motor will be less, and the range will be more. And again you must select the motor according to that, and again you must select the display for that. And next one will be the battery. So see here I have shown three different batteries, right? The first battery is a lithium ion, and second cell. So actually this is a cell, it's not a battery, it's a cell, it's a single cell. And next one will be also an, just a minute now, just a minute. Sorry for the interrupt. Uh, so first one will be a lithium cell, and next one is also a lithium cell, and the third one is also a lithium cell, and first one is an NMC, that is lignium, that is lithium, magnesium, cobalt. It is pure NMC cell. So the cell code is 18650. 18650. So these cells are used. I think you know Tesla car, right? So everyone know Tesla about Tesla. Tesla car. Tesla car has this cell, the single cell, the group of cells, and this group of cells are arranged in series and parallel to meet out the voltage and current values. Okay, and this is also an lithium ion cell. This pure lithium cell, and this is also pure lithium cell. So this is 18650. The cell code is 18650, and this is having an voltage of say 3.8 volt. Right, the normal voltage is nominal voltage is 3.8 volt, and the minimum voltage is 3.6 volt. You can't go below this 3.6 volt, and the maximum voltage charging voltage is 4.2 volt. I will show the data sheet, and again the maximum current that the lithium can able to, this lithium cell can able to deliver is about it will vary depend upon the different types of cells. So all the cells are 1850 cells. It will be vary around say 2400 milliAh to 2000 milliAh, or even some cells can able to deliver the current of say 3000 milliAh. Right. So what do you mean by 3000 milliAh? That is, it can able to deliver the current of 3 amps per hour for an hour. For an hour, it can able to deliver the current of 3 amps. Okay, so once we are having a number of cells like so if you want to have an say 6 amps of current, then what you will be going to do? You will be connecting the cells in parallel, right? So if you are going to connect it in parallel, then what happens? You can able to deliver, you can able to get the maximum current of 6 amps from that cell. And what will be the voltage range? It will be voltage range is around 3.6 volts. So if you require an voltage of say 48 volt, then what you will be going to do? You will be arranging the cells in series. Okay, so 14 cells in series, so you can able to get an cell voltage of say 48 volt. Right. And speaking about the cell number 1, and what about the cell number 2? The cell number 2 is also an lithium cell. But see the difference between the first cell and the second cell. The size is something large, right? Compared to this, it's large. So if it's large, then what happens? Obviously, it's having a more area to occupy the charge. So it can able to deliver the more amount of current when compared to the cell number 1. Right. So it's yes, it can able to deliver the current of say about 5 amps. That is 400 milliAh to 500 milliAh per hour. 500 milliamps. So what about the voltage ranging? Voltage range is similar to that of our lithium. That is cell number 1. Right. So what about the cell number 3? It's a lithium ferrophosphate. So now every batteries or every e-vehicles are coming with an lithium ferrophosphate, not about the lithium ion. So why lithium ferrophosphate? The lithium ferrophosphate. So for that we want to go for an. What happens if you are going to discharge the maximum current from that cell? What happens if you are going to discharge a more maximum amount of current of the cell? Say for example, you can lift a weight of say 50 kg, right? So somebody are asking you to lift an weight of 50 kg for an 1 hour, but what happens? It will be producing a stress in you, right? your body will be get a heat, that the body temperature will be getting up, and you will be putting in more amount of effort to lift that 50 kg for an 1 hour. Then what happens? Obviously the performance will be decreased. The same thing will be going to happen in the cell. So if you are going to load the cell, if you are going to observe the maximum or current out of the cell, then what happens? The internal resistance will be every cell will be having an internal resistance. Internal resistance in the sense, not only the lithium ion cell, even the lithium polymer, lithium ferrophosphate, lithium that is lead acid. Every cell, every battery, generally speaking about battery, every battery will be having an internal resistance. So if you are going to observe the more amount of current from that cell, then what happens to that? The internal resistance will be increased. If the internal resistance is increased, then what happens? The voltage drop occurs, the resistance will be increased. If the voltage drop increases, then what happens? The output voltage will decrease. Right? So this will happen in every electric vehicle. If you are going to accelerate at very high speed, then the temperature of the battery will get increased. You may came the news that the lithium ion cell will be get fired. Why it get fired? You are accelerating more. You are need more power, and so uh, you are just observing more amount of juice from that lithium. So lithium cannot able to deliver more amount of energy as you required. So the temperature of the cell will get increased. So because of this increase in temperature, what happens? The cell catches fire. So once the single cell catches the fire, the whole cell will catch fire. So this is the problem with the lithium. That is, the ionic change will be very rapid in case of lithium. The controlling of the ionic change is very very tedious in case of lithium. So the lithium is more more dangerous when compared to the lead acid. But it's not in the case of lithium ferrophosphate. Lithium ferrophosphate, even though you are going to accelerate much more when compared to the lithium, the internal resistance will not increase beyond some certain value, and the cell temperature is also not going to increase. But you can see the difference. The performance of the lithium vehicles will be more when compared to the lithium ferrophosphate. It's a gradual. If you are going for a lithium ferrophosphate, you can accelerate at the very gradual speed, but you can go for a rapid increase in speed in case of a lithium ion. And next one will be the BMS. So what do you mean by the BMS? It's a battery management system. So it's going to control the whole battery pack. The battery pack, in the sense, you will be having a series and parallel combinations of cells, and you will be having some group, and this BMS will be going to monitor the voltage of each and every group. And if there is any difference in single group, this will shut down the whole battery pack. So this is all about an BMS. Actually, the BMS will be the main part in the batteries. Okay, there are different BMSs are there. That is smart BMS. Smart BMS in the sense you can able to monitor the cell voltage, cell current, and even cell temperatures in the BMS in the app. And next one will be the cell holder. If you are fabricating your own battery pack, then you must have all those components. If you are going to purchase the ready-made battery pack, then it's quite okay. But you can't able to say what is the ampere hour of the battery. So what do you mean by ampere hour? Ampere hour in the sense that how much amount of current it can able to deliver for an hour, right? So for that, that is for holding the cells. To make and pack, you want to you will be forming the group of cells, right? To hold the cells, you require an cell holders. And again, nickel strips. The nickel strip is used to join then cells. Actually, this is used to join the various cells. And next one will be epoxy sheet. The epoxy sheet used to isolate an battery. Actually, we will be uh, making the pack for a different size. So different size in the sense for a different dimension. If you are going for a different dimension, then you can't go for a standard size. It will be a customized size, and if you are going for a customized size, and you will be placing an battery over one pack to another pack. Just you will be folding. Say for example, if you are having an 14 cells in series, you would like to fold after three cells, you would like to fold the battery. Then what happens, you will be placing the insulation sheet between these two pack, and this insulation sheet is an epoxy sheet. And next one, you will be wrapping all those things, and finally you will be going to make and pack. For wrapping, you will be having this insulation sheet. This is also an insulation sheet, but it's an glued sheet. This is non-glued sheet, and this is glued sheet. And next one, component, and these are some of the components like chargers. So the chargers you want to select. What to say that if you are going for an 48 volt 30 Ah battery pack, and you must go for an say 10 amps charger. So why I am saying that 10 amps charger, so we will be calling it as C rating. The lithium cells are rated with the C rating. What do you mean by C rating? C rating is say for example, I am saying that 3.6 volt 200 milliAh. So what do you mean by 200 milliAh? The 200 milliAh is the C rating, that is rated current that the cell can able to deliver. Right. So if you are going to charge below 2C, what do you mean by below 2C? Below the twice the rated current. Okay, that is 5 amps. So if you are going to charge the cell for at the rating of 5 amps, not 5 amps, that is it's an I am speaking about a battery pack 40 Ah. So for 40 Ah, if you are going to charge the cell for an C rating, what will be the charger rating? It's 48 volt 30 amps, the rated capacity. So if you are going to charge the cell below 3C, then what will be the charger rating? 48 volt 10 Ah. So if you are going to charge the 48 volt 30 Ah battery with the charger of 48 volt 10 Ah, how many hours it will take to charge the how many hours it will take the battery to full? It will take 3 hours, approximately 3 hours, or in some other cases it may take 3.5 hours. It's depend upon the that is voltage rating of your in your home, and again output of the charger, right? And next one, connectors. Then because you are going to rewire everything, and you require an automotive connectors and obviously wires, and because you know that you are going to remove the whole engine set, right? So in case of an scooter, you can see the swing arm, that is the shock absorber. The shock absorber is connected is just connected with the engine itself, right? And you can see that when you are going in a speed breaker or speed breaker, what happens is that the back wheel alone go up and come down, and similarly the front wheel will alone go up and come down. And this engine is attached to the chassis in such a way that engine is moving separately and chassis will be moving separately. It will be just attached with the bolt and nut, and these two are independent. Okay, you can move the engine separately without moving the chassis, and you can move the chassis separately without moving the engine. So what is actually behind this is we will be calling it as a swing arm, right? So this is the swing arm. So this swing arm that you want to do with your own, you may go for and help with some welder or some mechanic to design the swing arm for you, because the swing arm is very very important part in the electric vehicle conversion. That is just making an alignment with your front wheel and the back wheel. So these two should be just aligned each other. So if not, then what happens is that the front will go in different axes and the back will go in separate axes, and you will be having, while running, you it will just wobble. Okay. And you must think about whether you are going for a single shock absorber or a double dual shock absorbers. So most probably the preferable one is the dual shock absorbers. But in your scooter, you will be having an only one shock absorber at the for the back wheel. So you can see only you will be having an only single shock absorber for a scooty type of vehicles. But here we are going to use an dual vehicle, that is dual shock absorbers. So this is just an battery pack. See, so here you are going to arrange the cells in parallel so that you can able to increase the current rating. So by putting the cells in series, what happens is that you can see the voltage is keep on increasing, right? So this will be the battery pack. The battery pack will be like this. You can see the picture. It will be like this. Okay. And there are different types of techniques to make a battery. That is, if you are making the battery like this is the ordinary arrangement. Ordinary arrangement in the sense you can see the cells are arranged in series and parallel in a matrix form, right? But here you can see it's arranged in the different form. It's an honeycomb design. The honeycomb, if you are going for a honeycomb design, you can go for a more number of cells for a same area. Okay. And here I am going to have, I would like to compare the different types of cells. This is actually a data sheet of 21700. 21700 cell is, this is the 21700 cell. Okay. 21700 and 32650 is a lithium ferrophosphate cell. See, I would like to add one more point here. So see the cell size. This lithium ion cell will be somewhat, the size will be larger than the lithium ion. So what happens if you are going for a battery pack with the lithium ion, lithium ferrophosphate, for the same power density, that that is size will be more. That is the we will be calling it as an energy density. So for the same energy density, the size of the lithium ferrophosphate will be high. But in case of the lithium, it will be small. So for that reason only, for an compact vehicles, we are using lithium ion. For an say like a loader type of vehicles, we will be using a lithium ferrophosphate. And lithium ferrophosphate is also having one more advantage. Sorry. Lithium ion is lithium ferrophosphate is having one more advantage. So I would like to see the life cycles. So this is the core important between the lithium ferrophosphate and the lithium ion. So normally the lithium ion will be having a less life cycle, that is charging cycle. We will be calling it as a charging cycle. What do you mean by charging cycle? The charging cycle is that you are going to charge the battery up to its full capacity and you are going to discharge the battery. So if this cycle completes, then it's called an you can say that you have completed one charging cycle. So for lithium ion, the approximate charging cycles, see here you can see that it's an 500 charging cycles. So while selecting the battery, you must ask the vendor to provide the data sheet of that particular cell. Okay. So, and you must read the data sheet, and after reading the data sheet, you must keep in the mind how much charging life cycles that the battery can able to withstand. You must normally you must go for a higher charging cycle batteries. So this battery is having an 500 charging cycles, And so this is the case of lithium ion. And speaking about lithium ion, the lithium ion is 21700 and 18650. These two cells are lithium ion cells. And when you are going for that, these two cells are having a different category. So different applications, for different applications you will be having an different cells. So what do you mean by different applications? Say if you are going for an solar applications, then you will be having a very less charging cycles. So you can be able to select the battery with the very less charging cycles. They say for 500 charging cycles. So there you are not going to discharge the battery as in case of an electric vehicle. But in case of a vehicle, you will be using the vehicle frequently, right? So say for example, approximately you will be charging an vehicle for an single day. For an each and every day you are going to charge this, charging the vehicle. So if you are going to charge the vehicle on every day or on daily basis, then what is the approximate time of that lithium ion? It approximately about 2.5 years, right? Approximately 2.5 years. So if the battery cycle is about 1000 charging cycles, so you must select the battery. So that battery must have the charging cycles greater than 1000. If you are going for a 500 charging cycles battery, then it will just lose its life after 1.5 years. After 1.5 years, what happens? After 500 cycles, what happens to the battery? The efficiency of the battery is reduced to 80%. Right. So you must keep in the mind about an charging. So what happens actually after 500 charging cycles? After 500 charging cycles, what happens is that the internal resistance of the battery will get increase. Okay. So the battery cannot hold the voltage as it was new. Okay. So this is the problem with the lithium ion. But in case of a lithium ferrophosphate, you can go up to 1000 charging cycles. 1500, and even some batteries having around 2000 charging cycles. So see, if it's 2000 charging cycles, you can go up to 5 to 6 years. You can just forget the battery. Okay, but the only problem is that you can't accelerate as quick, and the energy density of the battery will be, that is the energy to volume density of the battery will be more. That is, the size of the battery will be more for the same rating of the lithium ion. Okay. So these things we must calculate. So here I just put the simple calculation to find out the battery capacity. And say for example, if you would like to travel the distance of approximately 200 kilometers, and you are running the speed of 20 kilometers per hour, and you are having the motor which is going to draw the more amount of current from the battery is approximately 5 amps. And the acceleration loss, what do you mean by acceleration loss? That is, you will be not going to keep on running the vehicle at the same speed. You will be accelerating, and you are keep on accelerating, and this will be happening in every vehicles. So due to that, vehicle will take some time to reach the new speed, and again it will take some time to settle down if you are deaccelerating, and this will happen. So because of that, there will be some losses, so which is called an acceleration loss. And effective current. And effective current, what do you mean by effective current? And actually, you know that we are electrical engineers. We know that because of the absence of the back EMF, the motor will draw the more amount of current at the initial time, right? So just we are going to multiply by that 1.05. So the efficient effective current delivered to the motor or delivered by the motor is 5.25. Putting all those things together, P equal to V into I, so we can be able to find the core that our motor is drawing the power of, say, 378 watt, right? So the 378 watt power is consumed by the motor at the 20 kilometer of speed. If you are going to accelerate, then what happens? Then the motor will draw more amount of current. So just we are going to take an example for you are driving a vehicle at the 20 kilometer of speed. So we are going to design the battery pack to run the vehicle at the vehicle for the 200 kilometer of distance. See, we are going to say that travel ratio. The travel ratio, total travel divided by travel speed. So total travel is 200 kilometers, and total speed is 20. So it's actually 20, 10. So travel ratio is 10. Then putting together in that, we can able to say that 3.7 kilowatt hour of battery is required for an travel distance of 200 kilometer to complete the travel distance of 200 kilometer, right? So that we can be able to say that the battery capacity is the battery efficiency. So we will be keep on speaking about battery efficiency. So even though it's an pure new lithium ion and pure lithium ion cells, it cannot able to deliver at maximum efficiency. So always we will be having and maximum we will be considered the maximum efficiency of 85%. And now you can see that you require an 4.4 kilowatt hour of battery to travel an distance of 200 kilometer, and you are running the speed of 20 kilometer per hour, right? So here I have did some math and for an different speed ranges, and at the speed of so see here at 20 kilometer speed you are having an the motor is drawing the current of 5 amps, and similarly for an 50 kilometer of speed your motor is drawing an say current of 15 amps. So here, so this is your motor voltage and this is the motor power. And finally you can see if you are going to accelerate much fast, then it requires a more amount of current. And next one, either now you have an battery with you, and you are having every accessories like a display, and you have written wiring for your motor, your vehicle, everything with you. And now you are having a confusion that either whether I want to go for an hub motor or I want to go for some other motor. So that is mid-drive motor. So mid-drive motor, the Ether vehicles and Ola vehicles are having a mid-drive motor, and among from that every vehicles are an hub motor, that is real wheel drive. You will be having a hub motor which is connected with a wheel, and this motor will be running that or moving the vehicle. And again you want to decide whether you are going for an mid-drive motor or an hub drive motor. So because in the mid-drive motor it requires a more amount of mechanical work, and that is you want to design the pulley, and you want to do the some driving mechanism like an belt drive or an chain drive. You want to do everything with that, and it's a complicated work. But in case of an hub motor, just you are going to connect the motor, that's it. The motor will be going to take care of everything. And putting everything together, and you can see the price for converting an electric vehicle, a conventional vehicle, into an electric vehicle. What will be the cost, approximate cost? So this cost is for an range of say 35 to 40 kilometer. Okay. So even you can run beyond 50, not more than 50, maybe 50 kilometer. So if you are going to run more kilometers, then you want to go for an battery pack, some different types of battery packs. So these are the price ranges. This may vary, depend upon the vendor, the price may be vary. And again you want to do your own wiring. And one more thing, here you want to protect the motor. So in case of an IC engine, what you will be going to do, you while applying brake, just you will be deaccelerating your accelerator, or you will be closing the accelerator, and your engine will get the engine speed will get reduced, or you will be having some clutch type of arrangement to reduce the speed between your engine and the wheel. And normally the engine speed will be different from the wheel speed in every motor, in every engine, that is IC engine. The engine will be running in a different speed, and the wheel will be running in the different speed. And even for all the vehicles, that is the vehicle engine will be running in different speed, and the wheel will be running in a different speed. And in between that, you will be having some gear setups and clutches. And clutches will be normally used to waste the excess power which is generated by the engine or else from your vehicle, right? And in case of an electric vehicle, you want to just detach the motor from the power supply while you are accelerating, while you are applying the brake. Okay, for that we are using some relay, and again you want to do some regeneration. And if you are going to apply an electric, you can apply electrical brake. In case of electrical motor, you can able to apply the electrical brake. You know that there are different types of electrical brakes. Electrical braking techniques are there. That is plugging and regeneration, and applying a DC voltage to the stator. There are likewise, there are different types of braking setups are in electric vehicle. In electrical motor, you can apply an electrical brake. So for that, we have fabricated our own PCB, and this is the actual thing. So I have bought the ready-made display unit. I have just modified the display. And for battery making, either you can go for the existing battery, a ready-made battery pack, or you can have your own battery pack. For designing your own battery pack, you require some spot welders. So these are the spot welders, different types of spot welders. And this is the compact spot welder, where you can charge, and you can portable spot welder. You can charge, and you can just take this, and you can do spot welding. And again, this is then spot welder which can able to deliver the current of say 600 up to 600 amps. It can vary from 100 to 600. You can just adjust that. So for that, I have procured, I just fabricated this spot welder. And for that, I have bought a microwave oven transformer, and this circuit from China, and again also this circuit from China. I have bought this, and just I have made the custom design spot welder. And this is the making of the battery pack, and this is actually lithium ferrophosphate battery. And you must check the voltage of the cell, each and every voltage of the cell. The cell voltage should not get changed. So say if you are having say 150 cells, 150 cells should have same voltage. So if not, then what happens, there will be an voltage imbalance will be there, and your BMS won't allow the battery pack to turn on. So this is an battery BMS. The BMS will be looking like this. So this is some normal BMS. You can go for a smart BMS. Okay, and this is actually, so see here, you can able to just fold from at this point. At this point, we can able to fold, and to isolate these two cells, we will be placing an insulation sheet. Okay, epoxy sheet. So this is the final conversion. I have converted the that is kinetic Honda into an electric vehicle. So this is the battery pack and everything, and just I have repainted the vehicle into a silver, right? And just we have translated the vehicle from this to this. So thank you all. Any doubt, any clarifications?
Thank you, sir. Participants, if you have any doubts, kindly ask in the chat box, or you can unmute yourself.
VEERAKUMAR sir,
Sir?
presentation is nice.
Thank you, sir. Thank you, sir.
I think good presentation in the PPT also is very nice.
Thank you, sir.
And also our students got a lot of information in this presentation. That means in nowadays no one to give battery. That means battery calculations to go for electric vehicle.
Okay,
Very few only know about battery calculation. The battery capacity, how to select the battery with capacity.
yeah,
So
yeah,
this type of calculations are, I think, very good for our students to go for electric vehicle related projects and all things. Thank
yes,
you,
sir.
sir.
Yes, yes. So even the if the students required, we can go further beyond that. Again, we are ready to give an lecturer on how to make an battery pack and how to diagnose an faults in electric vehicle and how to fabricate their own that is controller for an motor and how to find the faults in motor. There are different steps, sir. So actually we are plan to establish the center of excellence for electric vehicle in our college premises. So it going to have everything that is from starting from BLDC motor performance testing and again the battery pack testing, everything. If students are willing, and because I would like to add a few points, that is India is moving to electric vehicles. Maybe in 5 to 6 years, all two-wheelers will be just converted into an electric vehicle, and there will be a huge scope for an electrical engineers in this area.
Thank you, sir.
Thank you, sir. Thank you.
Thank you, sir.
Next.
Yes, sir. Thank you, sir. Thank you so much for such insights, and we believe our audience would have grasped all the important information. Now, I request Dr. M. Sasikumar, sir, to give the e-momentum to our speaker.
1 minute. Okay. Veera sir,
Sir.
kindly accept our e-memento.
Thank you, sir. Thank you, sir.
Thank you, sir. Thank you, ma'am. Now, I would request Ms. Nasreen, our student volunteer, to conclude with a closing note.
Can you hear me, Miss Bharati?
Yes, Nasreen, you're audible.
Thank you so much. Thank you, sir, for sharing such a great insight for us. Personally, I indeed exposed many windows of opportunity in e-vehicle, and I believe our audience had great virtual experience and exposure. Thank you for joining at the middle of your very busy schedule, and thank you everyone for making this wonderful event a pleasant day. Thank you so much.
Thank you.
So thank you all from JPR group of institutions to giving me this opportunity. And if at all, if you are having any doubt, you can feel free to contact via Mr. Sasikumar. Thank you all. Thank you.
Thank you, sir.
Thank you, sir.
Thank you, ma'am.
Thank you, everyone, for being a part of today's event. Feedback link will be posted in the chat box. I request all the participants to fill in. And we'll be having another session tomorrow, and I request all your presence tomorrow. Thank you so much for joining us.